Good morning. We'll go ahead and call the meeting to order. First item is our public comment. Issues or items that are not on the agenda may be raised by the public at this time. Citizens should speak from the podium, begin by stating their name, and limit remarks to less than 3 minutes. Board members may request that a discussed item be placed on the future agenda, and the Water Advisory Board takes public comment on all regular agenda items during the discussion of those items. Is there any public comment this morning? Anyone to start to kick us off? Okay. No public comment. We'll go to regular agenda item. Consider approving the May 24th, 2017 minutes.
Motion to approve.
Got a motion by Mr. Hirschfield. Is there a second?
Second.
Second by Mr. Weiss. All in favor say aye.
Aye.
Any opposed? Motion carries. Item B, update and discussion on water utility master plan. Mr. Bill Riley.
I'm actually going to introduce our consultant from CDM Smith. Last year we recommended to y'all and council that we proceed with the water master plan. I just want to remind that this focuses on our distribution system. It doesn't do any of the raw water type analysis. It's just the finished water and throughout the city. And I have Alan Wilkie with CDM Smith, and he is going to do this presentation for y'all today.
Okay. Good morning.
Good morning. So we've been working on the water master plan for several months now, and this is kind of a almost across the finish line update on where things are. Master plan, what we worked on, can be broken down into 4 different areas. One is the creation of a water system model, which we'll talk about a little bit. Then there's the actual evaluation and master planning of the distribution system. There was a leak detection portion of the master plan. And finally, there was a master plan renewal and replacement asset management portion of the master plan as well. All those components rolled into what will become a CIP for the water system moving forward. So the next 15 or 20 minutes, I'd like to go over each of those, kind of give you an update of what happened and how it all builds and works together. So a water model, basically this is in distribution systems, there's thousands of pipes. In the city of San Angelo's system, the computer model that we put together had 23,800 pipes that each are individually modeled that represent us over almost 700 miles of piping that's in the system. To comprehend that in a way that can be analyzed, and you can say, well, gosh, what if we have a fire downtown on this 6-inch line? What happens? What the industry has done is develop computer models that can look at all 23,000 of these pipes and calculate the flow through the pipes as it comes from the pumps to the fire hydrant, or from the pumps and elevated storage tanks to your individual service connection, so that we can know that the system can meet not only the TCEQ requirements for pressure and flow, but also for fire flow. And you can also use it, further that, for what-if things that we'll get into in a little bit. So the development of the water model, the pipes are in the system. So we have 23,000 pipes that are in the system that range from, and when we say 23,000 pipes, it's from, you can see that right here, you have several different pipes that are come together. This one here is an individual pipe, and this is an individual pipe, and this, anyway, each of those is individual pipes that make up that 23,000 pipe system. So each of those is modeled independently in the system, and then the first thing we do is try, after that, we put that together using GIS data, which the city had very good GIS data to work off of. The next thing we do is try to determine what the demands are on the system. And to do that, we actually took billing data from the city's water meter data and found what each customer was using and added that into the computer model so that each individual customer can be modeled in the system. We also use SCADA data that is available to look at tank levels and pump rates and things like that. And then finally interviewed the staff about how the system actually is operated and how they've been operating the system. There's a calibration step, so we put all this information into a computer model. It runs, it gives us results. The next question is, are the results reliable? We actually did fire flow testing in the system back in the winter this year, and calculated what the flow rates were at those fire hydrants versus what the computer model would tell us would be coming out and what the pressures would be, and found that the computer model did a pretty accurate job of representing the actual system. Now, uses for the model, one is to evaluate the existing system to serve future demands. So a new development comes in, wants to connect onto the edge of the system. Is the system big enough to meet the demands of those houses, those public facilities like schools, and can they meet the fire flows? You know, fire flows are very important in order to keep, you know, public health and safety in check and being able to fight fires. Because that's the first two. Also can be used in planning and using this model for the how the system will operate. What happens if we have to take a ground storage or elevated storage tank out of service for maintenance? How is that going to affect the system? What valves do we need to change in order to compensate for that piece of or that asset being out of service? That can be used also. Can also be looked at operational changes. We'll talk a little bit about some of the results and the water age that's in the system and how that impacts the quality of the water, and how the model could be used in the future to look at what if we change the pressure plane boundaries, what would that have, what impact would that have, good or bad? And talked about that on water quality. Now, one of the things I meant to mention and kind of slipped my mind was this is the first model or master plan that's been done for this community since 1998. Typically, these things are done every 5 to 10 years. So it's been well overdue that this be done. When we get done, we're leaving the computer model behind for staff to use so that they can continue to monitor and model the system. That tool hasn't been available to the staff at all. So this is a big step forward for the ability of the staff to be able to monitor and model the system. I told Bill the other day, this is a little bit like your map app. You know, if you wanted to travel from here to somewhere in downtown Austin, you know, you'd probably pull out your phone and enter the address and get there, and you'd follow it. This is a little bit like that map app. If we're going to add a new subdivision on the edge of the town, what do we need to do to get there? What do we need to do to have the ability to serve that development? The results in the master plan, so we build this model, use it, look at what the existing demands are, and when we look at demands, we usually look at 2 or 3 very important ones. One is peak hour. So if you can imagine, you know, during the course of the year, there's average day, how much we all use kind of on average, how much we use during a max day when everybody may be irrigating on their day to irrigate. And during that max day, there's a peak hour when everybody gets up and uses water at the same time. So that's usually the most critical, one of the more critical times on the distribution system. So we usually model the peak hour, and we usually model max day with fire flows happening inside the city. So what happens in that situation? The TCEQ has given us guidelines. Under that normal operating condition of peak hour, we can't go below 35 PSI. And during that max day with the fire flow, we can't go below 20 PSI, or we are out of compliance with the TCEQ. Based on the modeling we did for current and for 2040, so a little over 20 years in the future. Yes, sir.
When you say 2040, is that based on the Region F, the municipal demands, or city? I mean, cities supply that to the Region F, so.
Again, it's just for the inside the city, but we used the Region F population forecast, and I think we used in conjunction with the wastewater master plan, the population projections from internal. But I think they matched up pretty well with Region F.
Okay, thanks.
So in the evaluation, there are almost no pressure issues, so the system is fairly robust and able to meet both the peak hour and fire flow demands. There's a few, and we'll talk about a few of them. There's very few fire flow issues, and there's only some minor operational issues that we can talk about, and most of it has to do with water age and pressure zone boundaries. The treatment plant, Allison said it's the pipes. We do look at treatment plant capacity, only the capacity, and also elevated ground storage and pumping, and to compare that to TCEQ requirements. And everything on there looked just fine. So as far as compliance with TCEQ, I think there's one issue with elevated storage in the lower pressure plane, but that can be resolved by using a pressure reducing valve. There's lots of graphs, and we've spent multiple 4-hour meetings with staff going through what we're going to try to do today in 15 or 20 minutes. So this is some of the highlights. But if you look on this side over here, so this is the 2017 system, and we're looking at existing maximum pressures. And the only thing that's interesting about this, or that I want to point out here, is that the purple dots actually are 80 to 100 PSI. Building code says that without having an individual pressure-reducing valve, the system at a residence or business shouldn't be over 80 PSI. So there's some areas there that probably need to be, I mean, it's operating well, it's got a lot of pressure, but it's just whether that exceeds the building code requirement. In 2040, so this is out 20 years, you're looking at, again, this is the minimum pressure, so this is during a peak hour event. And you can see most of the system is in pretty good shape with, the green is 40 to 60, 40 to 80, and then the purple is the 80 to 100. The only areas that are problematic are right there. And we believe that some of that has to do with some small pipes on the dead end of the system. We're working on the CIP right now, the capital improvement plan, to address that. But we think that by maybe connecting the system with a pipe that does something like that, that can be resolved. Fire flow, again, the fire flow simulation are pretty good. There's a couple areas where there's some low fire flows. Fire flow is a little bit of something that's you have to look at individually. Individual houses. When I started in this business, a fire flow of 500 gallons a minute was considered pretty good. Now, if you look at the ISO, the Insurance Standard Organization, I think is what it's called, they recommend almost 1,500 gallons a minute for fire flow for a residential house. And so the requirements to try to keep the insurance rates reasonable have gone up. There are some areas here and I think there's some out here by the old airport, or by the airport, that are issues. But we think that we can address that again with some looping. There may be some dead ends there that are just having a hard time keeping up with some of the fire flows. So the red dots are less than 500 gallons a minute. The blue dots are 1,000 to 2,000, I believe. So plenty of fire flow for those.
Shouldn't that be a little bit of a concern that that's Angelo's state?
And that's why that we'll be looking at that area with the CIP. And it's probably a good thing we ran the model to find that.
I'm sorry, I didn't hear what you said.
It's ASU area, isn't it?
Area, isn't it?
Can you help us on that?
We're also going to follow up this, the calibration was done citywide, and so we can also do some calibration in that area specifically, just to double check the model versus actuals.
What's going to be recommended is that we actually do fire flow tests there and see if that's actually showing up as reality or not. And we'll also, can you put that down so we can make sure we put that in there? Anytime it shows up red, it does cause attention, and there probably is a project being developed to address that area. But we can also do fire flow tests there to make sure that that's actually what's going on. One of the other things that the model allows us to do is look at chlorine residual. The TCE cube says that we have to be able to maintain, and to still call it potable water, we have to maintain at least a half part per million chlorine. And so the staff has done some decay analysis where they've taken the water from the water treatment plant and seen as that water gets older, how the chlorine residual stays in that water. And it lasts a long time, but after it's been in the system a while, it will start to lose that chlorine residual and start to get to a point where something has to be done. The only areas that I think that are issues are up here. I think is that Lakeview, Allison? And then around Lake Nasworthy. And a lot of it has to do with the system. The system has a lot of good storage, makes it great to operate the system, and there's a real benefit from the quantity standpoint. But there's also a lot of days spent in those tanks that causes the chlorine to be a little bit of a residual issue. Again, we're working on things that will help address some of these areas. Some of it may be that if moving the lake pressure plane into the low pressure plane might help reduce some of the areas in this area, or some of the low chlorines in those areas. This area we'll have to look at in a little more detail. said, we did a regulatory analysis. The TCEQ has several things that they have us check to make sure that you're in compliance. Elevated storage is one of them, ground storage is one of them, and then pumping. And it's a kind of Byzantine way of going through checking and seeing if you have this much elevated storage, you get this much pumping. If you have this up to elevated. So we go through that process and everything. The only issue was elevated storage in the low pressure plane. But if we can put in a pressure reducing valve that allows us to move some of the water from the high pressure plane to the low pressure plane, we can use that elevated storage, excess elevated storage there to meet the elevated storage requirements in the low pressure plane. Now the third part of the master plan was the leak detection program. So we contracted with someone who does acoustic leak detection to evaluate 100 miles of the city's system, looking for leaks that might be causing water loss that, happened underground and nobody knows about. The areas on the map here are the areas where those 100 miles of pipe were evaluated. Again, 100 miles is about 1/7 of the whole system. For the most part, they found very little leaks in the system. It was a very tight system. We were very happy to find that. Most of the issues were found were actually service lines and meter boxes. So the main lines themselves had very few problems.
Is 1/7 study good enough?
I think so. It's probably something where it would be good to do that every few years to keep that program going, to look for those, because we picked in conjunction with staff the areas that we thought might be the biggest problems and found very little, which is good. So the question is, would you want to keep doing 50 to 100 miles a year just to keep looking for those leaks?
I would think so. I think we'd want to build that into the plan where that way we get over, 6 or 7 years, you get complete coverage.
So the hydraulic system itself, the distribution system itself is in good shape, but some of the pipes are fairly old, and all these infrastructure pipes that we put in the ground have ages that how long they'll last until they finally wear out. There's 700 miles of pipe in the system. Some of it dates back pretty far. So one of the things that we did was an asset evaluation to see how old the pipes were, how good a shape they were in, based on some recorded data that we have, and then tried to come up with a plan that would help the city direct its resources at addressing the most critical pipes first. So this is a very interesting process, and I'm going to try to go through it. We spent 4 hours on this on a phone call a couple of months ago, so I'm going to try to hit the highlights again. And if you have any questions, just let me know. The first thing we looked at was break data. So we looked at 5 years of break data, and we had about 964 breaks were recorded in the city's work order system. Of those, 884 were what we analyzed on the existing pipes, so that those pipes were tagged as potential problems from the very beginning. The next thing we did using the GIS system was look at the age of pipe and the material that pipe was built out of. This is a graph showing, based on the available data that we could find, when the pipe was installed, how many miles of pipe were installed in each year, and the color coding is the material of the pipe that was being installed. So you can see there's big developments in the 50s and early 60s, again in the early 80s to mid 80s, and then 2002 to 2012. So those are the miles of pipe that were installed and the material that was being installed. So plastic pipe doesn't have to worry about corrosion for the most part. It does have ductile iron fittings and has ductile iron valves, so it does have some corrosion points. Cast iron, metal that could potentially corrode. You got other materials out there that have different lifespans. The next thing we looked at was what the lifespans of these different pipes are. So AWWA produces, through all the historical records that they've had with utilities, their best estimate of how long each of these pipe materials will last. And what you're looking at here is on the top, the optimistic assessment, and then on the bottom, the pessimistic assessment of how long those will last. So can you count on it lasting 150 years, or can you count on it lasting 100 years? And Again, the color coding is for the different pipe materials. And you can see that the cast iron and is out there pretty far for some of those. This gets used to start looking at how long the system is going to last and which pipes are going to be the first ones that need to be replaced. I have 28,000 pipes in the system based on the GIS and the water model. This analysis is done on all 28,000 of those pipes. So we know the age of those 28,000 pipes, and we know the materials for the most part. You can see some are other and some are unknown, or the UNK is unknown, so obviously we don't know all of them. The AWWA also recommends a 1% replacement per year. And again, that 1% replacement per year is based on a life of about 100 years. So as your pipe gets old, you're going to be replacing about 1% of it a year to keep up with the aging and deterioration of the pipe. What we have here, again, is two graphs. Again, the first one is, the top one is the optimistic one. That's optimistic life. So, and on the y-axis, you have miles of pipe. So this would be the number of miles of pipe that would be replaced every year just based on the age. Right now, if you look at the 1% per year, you're looking at a number out here of about 6.5 to 7 miles per year. And if you look at the optimistic rate, we would need to be replacing about 9 miles a year in about 2040 to 2050 timeframe. On the pessimistic side, we're looking at replacing about 10 miles of pipe in the 2030 to 2040 timeframe.
Sorry, is 865 breaks normal for 5 years? I mean, I'm trying to relate, is that good, bad, okay?
It's about average.
About average.
About average. Based on the number of studies we've done across the United States, you know, it comes down to breaks per mile, and the breaks per mile is about average. Not anything more, it's not like it's a lot worse and it's not a lot better, it's kind of in that, you know, in the average range. So again, in an effort to try to direct limited resources to the most immediate problem, there's an analysis, a risk analysis that's done. And the risk analysis consists of two different components. One is the probability, I like to use the word likelihood of failure. So how likely is each of those 28,000 pipes to fail? And then to come up with that likelihood, these weights are used and these factors are used to come up with that likelihood that it's going to fail. Some of it's age, some of it's these other things. And the higher the score, the more likely it's going to, or the bigger the impact is. So some of the things like soil resistivity, it goes back to, you know, if it's a metal pipe or even PVC with metal fittings, it's going to have more likely that that metal is going to corrode. Another one is proximity to groundwater, because again, if it's wet and dry, it's going to corrode faster. All 28,000 pipes were evaluated for those criteria. That's one part of the equation. The second part of the equation is consequence of failure. Now, the best way to think about this is if you had a single service out on a county road and the pipe broke, yeah, it would be an inconvenience for the one or two customers, but it's not too big a consequence. It's a big consequence to them, but system-wide, it's not a big consequence. If that pipe broke in front of the hospital or in front of the high school or in front of another public facility, that would be a bigger deal. And so what the consequence of failure does is it tries to put a value on how big a problem is that going to be. Obviously, if it's the pipe that's right outside the water treatment plant and it breaks and the whole city goes out of water, that's a pretty big consequence. So those are the kind of things that get loaded in. These 17 items get loaded into those 28,000 pipes.
So just make sure I understand kind of the formula of where you're getting to. And I may be getting to your punchline, but you take each one of those 23,000 pipes, and then you factor each one of these items for each pipe based upon all those criteria that you
get that.
Okay, sorry, I was jumping
That
ahead.
was a great segue. Thank you very much. So you get this. So all 28,000 pipes are being looked at from the standpoint of the likelihood that it's going to fail, and then what happens, how bad a deal is it for us if it does break. And So there, and we create this 5x5 matrix where the top row is likelihood of failure. So again, if it's very likely it's going to fail because it's a 100-year-old pipe that's got the wrong material and it's a highly resistive soil and it's next to the ground, all those things in it, it's highly likely, extremely likely to fail. And it's in an area where it's an extreme consequence, say in front of the church or school or something like that. There's 3.2 miles of those 700 miles of pipe in the system that fall into that category. Each of those pipes, because of that score, the likelihood of failure and the consequence of failure, have a risk score that's assigned to it. And what we try to do with this analysis and this approach is try to limit or reduce the amount of risk that the system is under to make it more robust, more reliable, but do it in a way that we're not just throwing money at pipe. Oh, that pipe broke over there, that 6-inch pipe broke, we need to replace that whole block of pipe. Well, no, not really, because it's not that big a deal. It's just serving a little bit. But maybe we ought to think about replacing the 100-year-old pipe that's in front of the hospital because that's a bigger consequence of failure. So it combines those things into something that helps put together a plan for the city and its renewal of its assets. So we looked at a couple different scenarios.
I go back to the, I'm sorry.
Yeah,
Wow,
sure.
that's loud. So again, as you do these assessments in other places, what is this, how does this kind of compare again, kind of across? Is that kind of an average ranking, you think, or?
I think so. Talking to one of our, I'm not the guy that actually did this. I'm not smart enough to pull this off, but the guy that does it, I think when we were having our meeting, said this was pretty typical. You know, you get 10% or you get, you know, 1 or 2% in the extreme, and then it kind of reduces from there. So I don't think there's anything unusual about it. It's just, you know, San Angelo's been here for a long time. We've had pipe in the ground for a long time, and some of those pipes are getting to the end of their useful life.
So
It doesn't look real scary on that high and extreme. I mean, that looks proportionate, looks to be
You have
pretty well in
about
check.
11 miles of extreme that are these guys right here.
Right.
11 miles out of almost 700, so that's a very small percent.
Any of the purple to me, or whatever we call it, the 70, 80 miles.
Yep.
So, I'm
This
probably
is-
getting ahead again, but this overlay will match our street overlay.
Well, you guys are right on the ball.
That's the question we've been asking for a long time.
You guys are right on the ball. So we have, we'll get this one real quick. So we looked at 4 different scenarios of how to do your renewal and keep up with the system reliability and addressing the consequences. One was the 1% renewal, which goes back to the AWWA recommendation. One is the optimistic renewal, where we're actually replacing that multicolored graph that we had. The pessimistic renewal, so you're replacing more. And this is the current renewal. So we looked at all 4 and what that would do. These are 5-year increments. So 2017 to 2022, 2022 to 2020. And looking at how many miles of pipe you would be placing under each of those, and then what your risk reduction would be in each of those. Now, the staff asked us to, and we're doing this right now, but the staff asked us to look at staying with the current renewal, but also being smart about that and looking at following the street, but doing it in coordination with the street program. So for the first few years, the street program has already been figured out in what we're going to do. So we are in the process of figuring out how many of those pipes, what the risk factor is for the pipes that are underneath the existing and adjoining, you know, branching off from those streets that are already in the street program. For the next 5 years, for years 5 through 9, we actually want to factor in the high-risk, extreme and high-risk pipes into possibly reordering the street CIP, so that we can actually maybe, if we have a host of streets that are going to be either replaced or overlaid or seal coursed, that we could actually get ones that have the biggest impact on the water system factored into it too. Sometimes, depending on the size of the water line in the street, the water line can be more than the street project. So at some point, we need to start looking at and doing those projects in kind of combination with each other to get the biggest bang, not only for the street buck, but also for the utility buck.
The replacement of those pipes still go under the street? Are we going to try and, is it even feasible to move that to the side like we talked about? So if you have a break, you don't have to tear it up again? How's that going to work?
Yes, sir. We are actually doing that in the Bell Street project. The current water line runs through, I think, the northbound or the northern lane.
Right.
And we're actually moving that water line where it is behind the curb. So if we do have those breaks, we aren't digging up the street. Some cases that might not be possible
Yeah,
because
no.
of other utilities, but we are making every effort to do that.
Good.
So this is the slide we've all been looking for, the summary. So just to kind of wrap it all up. So a water model is a very important tool, and that we will hand it over to the city, and they will, your staff, I think Andy was the one who's designated to operate the model for the time being, and we'll be able to keep that model up to date and be able to use it for different evaluations, you know, what ifs, you know, if you will. The good news is the water modeling showed that the system is pretty robust. It meets most of the demands from the standpoint of peak hour and fire flow, and we will check on those red dots just near San Angelo State. It shows that with some minor modifications, it can meet all the TCEQ requirements, and that goes back to the elevated storage tank capacity in the low system versus the high system. The leak assessment showed very few leaks, and I do think your idea, Mr. Boyd, of continuing that's a good one, because there may be one out there somewhere that needs to be found. The asset and criticality evaluation showed that age and condition of the pipe needs to be addressed in order to reduce the risk of failure. And we talked about that and how we're looking at each of those pipes. And then finally, the CIP is being coordinated with the road program so that we can put those two systems together. And I'm available to answer any other questions that you
Just
might
a
have.
quick question. I know the city had talked about the street program with the water program. We're going to do the water first before we do the streets, so we don't have to redo the streets again. That's still the plan to. Great.
That's an extremely normal thought. I'm proud of you, Chuck.
Can you go back to the, that slide with the pink, one more? Right there. Okay. As they're updating this model, I'm assuming that again, they're going to be updating this stuff so some of this data can be, actually become active and live, and so it could be almost time-lapsed in looking forward to the future. So as there's, you know, as they start to develop and create specific projects, because I realize that as things are, you're not going to clean everything off the extreme and the high, because other things will begin to move into that.
Right.
So again, how can we keep that going so, you know, while we attack those projects, that it can continue to move forward?
You want it always active.
Always
That's what we're
active,
saying. We
yes.
want it always active.
So the model that will be delivered is the hydraulic model. This is a GIS tool that runs separately, and we can deliver it. I don't think it's proprietary or anything like that. The biggest thing to keep this active and fresh is the GIS system. All this data on pipe age and all the information that was put into those 28,000 pipes came from GIS data. The soil resistivity, it comes from SCS or NRCS soil data maps that are been around for forever. All those are on GIS, and based on the soil type, you can look and see what the resistivity is. Groundwater tables, I'm not sure where they got that data right now, but most of that data was collected via GIS, and so those tools are in there to keep running that. But you're right. If 11 miles of pipe is replaced and it goes from, now that moves off of the high likelihood or extreme likelihood of failure, but now the pipes are 5 or 10 years older, so some of those guys are moving up into that area. Yeah, it probably needs to be looked at on a continual basis too. This is a snapshot in time. This, as of May of 2017, this is what the system looked like.
I just think that makes sense. You spend that money initially for what we got. Let's keep it active and look at it for whoever's here moving on down the road.
Really, the only variable is what's getting changed out and replaced. Otherwise,
Exactly.
all the soils don't change, right? I mean,
Mhm.
that's there.
Oils,
So-
groundwater probably
Groundwater.
doesn't
Yeah.
change. I mean, all those other likelihood factors are staying the same.
Right.
Age of the pipe is the biggest, age and material would be the two biggest things. And if that's being updated in the GIS, then that could be brought in, I would think, fairly simply.
Other questions?
Yeah, may I inquire? I'm not for sure what I expected out of this report, but to me, it's extremely encouraging to find that the system's capacity, its ability to qualify under TCEQ, its leak detection, it seems to me our system is in very good shape. And again, I don't know what I was expecting. How did staff receive this? Were you encouraged by these? Did you expect these results? Do you care to offer any comment about that?
We were glad to see the results, how they came in. And definitely, we're working closely with Alan on the lake pressure zone and that the storage capacity that he discussed about sending some of the excess storage from the high plain into the low plain, and working closely to kind of look at those areas where they have the low chlorine residual potential and how we can minimize that as much as possible. But overall, we're very happy with the results of the study.
Two. Was Goodfellow included in this,
Yes.
inside the wire?
Well,
We-
no.
no.
We serve them up to their fence line at
And that was it?
several
Okay.
areas, but inside their fence line is
Not?
no.
Okay.
They, based on the work that we did for the Navy, I'm sure, I know that's an Air Force base, but we did this for all the Navy bases throughout the world a couple of years ago. So I'm sure the Air Force is doing something very similar to this for that, for their own system.
Any other questions?
Excuse me, the only thing that I'd like to add to that is Kendall's comments about the low fire flows, and was that a concern? It is, obviously, and that's why we wanted to do this, so that we could have a good picture of what's going on within the system, so we could address those issues specifically. So I think that's the value of this, and I think that just the overall results, and the biggest thing is having this tool and being able to continue to analyze the
I
system.
mean, I'm surprised with only 11 miles in the extreme side. That was a surprise to me, so. Alan, yeah, I appreciate your report. Thanks for coming, Alan. Item number C, discussion of potential water supply options and consider recommending approval of a contract with Allen Plumber Associates in amount not to exceed $574,099. Mr. Bill.
Thank you. Yes, I wanted to visit with you about this project. I know that we had this on the council agenda recently, and I know that some of you felt like that we had not brought it back, and that was kind of caught off guard by that a little bit. So what I wanted to do is kind of start over and kind of recap of what we've done over the last year, and get to the point and kind of talk about what we had talked about previously, and see if we can move forward with some discussion about this project and the value that I think that it will bring. So just kind of a recap. If you recall, last year we did a SWOT analysis of the different water supply options that had been proposed both in Region G and that had been on the table and been discussed for some time. So we went through a process of over a couple of meetings of evaluating those and looking at those that we thought, just from a cursory look, if you will, which would be possible, and rule any out that we just knew would not be feasible. So in August, following that process, we discussed the possibility of the next step, which would be doing a study, a preliminary engineering study, to begin to really evaluate those options and our infrastructure needs. And the board recommended that we move forward with that. We talked about it again in November on the status of moving forward, developing an RFP, and then putting that out on the street and getting responses to that. And then in May, at the May meeting, we discussed that we were going to take that to council. So that's kind of what is the schedule that we've had over the last year in discussing this project. I realized that there had been some time between November and May, and we probably should have had a meeting. Well, we should have had a meeting in there, and had this on the table to discuss a little bit more. And in regards to that, just to go ahead and throw this out there, I think that we don't want to leave this meeting today without scheduling the next meeting. We need to make sure that we schedule the meetings every 3 months. Unfortunately, in the water business, we're not going to have specific things to act on every 3 months. I mean, in some cases, and I think we had a meeting like that this last year where we really didn't have much to new because of the things that y'all talk about, you recommend doing. Sometimes it takes a long time as we work on those specific issues, but I think it'd be important for us to continue to have a regular meeting, so we want to talk about that at the end of this meeting. So just kind of backing up a little bit and looking at our water supply and the issues that we're faced with here, it's clearly that our existing surface water supplies are vulnerable to drought conditions. And I think this slide just really kind of brings that home to us when we look at Ivy, our main water supply, that there's been 2 times in the last few years where we had less than 12 months supply. And we've talked about this. I don't think it's reasonable to think that Ivy will go away. But I do think it's important for us to be prepared that if there is a time period there that we don't have water in Ivy, and we have to bridge that gap some way. And so I think that's what we're looking at here, is how do we evaluate our supplies and look at the potential supplies and figure out how we bridge that gap, and then what we might do to have additional water for any projected growth in the short term. So again, just as kind of a reminder, when our current contract with Ivy is for 15,000 acre feet. But the safe yield for Ivy has been reduced considerably to a little bit less than 5,000 acre feet. Now, they have not, CRMWD has not adopted that, and so they're still allowing us to take the 5,000 acre feet. But I think it's important for us, for water planning purposes, we need to recognize that it could be the 5,000 acre feet. And so that is what we need to look at, what we can rely on from Ivy in the future. So that means that's the amount that we've got to bridge there if we have a shortage. Our other supplies, Twin Buttes, Fisher, and Spence, the firm yield or safe yield of those is 0, which means they have gone away at some point and have not refilled. So from a water planning perspective, there's not any water there for us to plan on. The Hickory well field, which we've talked about a lot, currently has about a 9,000 acre foot, has the ability to produce that. It's about 8 million gallons a day. So that's what we can currently produce from the well field, and we can treat. The pipeline is, and this actually has a mistake on it. It says 12 MGD, but I think it's 10.7 million gallons a day. It's about 12,000 acre feet, I think, is the max on the pipeline. Our treatment plant currently at 8 MGD. We've talked about the expansion of that, and we will be moving forward with the expansion of that. There's some ongoing issues with the initial phases of construction that we're working through, and once we have all those worked out, then we will be able to move forward with the expansion of Hickory up to its maximum 12,000 acre feet, both in the well field production and in the treatment plant. So that means that basically right now our current water supplies, we have currently about 13, just shy of 14,000 acre feet a year. So as we look at our projected demands, as we move out for the next 50 years, you can see that our projected water demand will be up to about 24,000, 23,500 acre feet. Now that's what that's projected demand, so that does not include any, additional water over that. So that's the number that we're looking at for the long term. We're going to need another 10 to 15,000 acre feet of water supply for San Angelo for the future. But the question today is how do we meet our demands if we have, if we in fact have Ivy go away, or if we have a failure in the Hickory. So what do we need to do? What can we do looking in the short term of the options that we have available to us that we would be able to not only bridge that gap, but to be prepared for any growth and support economic development today. So that's the objective of a comprehensive water supply plan that would begin to evaluate all of the options out there, because there really is no silver bullet. I mean, we can't go out today and say, here's the answer, we know what it is, let's go develop this. Unfortunately, that's just not what we have. So we really need to look at all the options on an apples-to-apples basis. And then a long-term water supply plan will, in fact, be a roadmap that we can use to take us into the future in preparing for and providing for the water supply needs of San Angelo. So these are the options that we have looked at previously, or some of them. And the point of this slide is not to go into these, but just to kind of point out, as you already know, there's several things that have been on the table. Some are viable, some might be viable, some we know just really aren't. One that's not on here is water that might be available out in the Fort Stockton area. Some changes out there that have taken place. The Groundwater District has changed their stance on issuing permits for export. And so that's potential water supply that we need to continue to evaluate. It's probably more long-term, but the point with that is that there's the dynamics of water supply across the state are changing all the time, so we need to continue to evaluate that and watch that and make sure that we're prepared and have a system in place to be able to address those concerns, evaluate those options, and make good, smart decisions. So what we're proposing to do is a preliminary engineering feasibility study for water supply. Again, the idea is to begin to compare all of the options the potential options on an apples-to-apples basis with both, in respect to both cost and the reliability of that supply. And then also look at them on a cost and non-cost basis. I mean, cost is one thing, obviously, but the feasibility of developing that supply has to be factored into whether that is a good option for us or not for both the short term and the long term. Again, the idea ultimately is to have a plan, develop a plan that takes into consideration what our water supplies would be and what our infrastructure needs in far as treatment in both wastewater and water treatment plants needs are, evaluating those needs with what our source waters will be so that we can have a good plan for upgrading those plants, and then ultimately combining that with the work that the West Texas Water Partnership is doing into for the longer term supplies, and have a 50-plus year master water supply plan for San Angelo that would outlive all of us, that could be implemented and have an understanding of what the options are, when we can implement those, and what the costs are, so we can plan for that down the road.
So Bill, it'll include not infrastructure, but plant design.
Absolutely.
To
Yes, sir.
handle that. Also, quality of water.
Yes.
I mean, we just need to improve the quality of water, not just meet the minimum standards.
Absolutely.
So it'll be, okay,
All of that's will be part of the evaluation.
Okay.
And then, of course, the preliminary engineering study is necessary for us to be able to apply for any state or federal funding that might benefit us. And then also looking at putting, as far as our, well, part of this obviously is we have, we've talked about DPR, and that's not part of this evaluation. But what is part of it is looking at how we might be able to use our effluent in other ways to help augment our surface water supplies. Putting it into the river, taking it out downstream, cleaning it up, putting it in the ground, or even taking our hickory water and bringing it here and putting it in the ground in an aquifer storage and recovery project. There's a lot of options out there that we just really need to vet to see if we can use what we currently have to benefit our future supplies as well.
Bill, why wouldn't DPR be part of that plan?
Well, I think that we've evaluated that stand.
On its own.
Right, and so I think what we've done there stands today.
Okay.
And so I think what we need to do is go beyond that now, and ultimately, all that's going to come back together. I mean, I think as we go through this process, one of the things that it will allow us to do is to really get a lot of input and feedback from first y'all, then the community, and then ultimately the council, And as we begin to pull all these pieces together, I think as we have the additional data that's going to be developed here, we meld that with what we've already done, it can make some good decisions going forward. So anyway, I've already talked through these and what the benefits of developing the plan is, and so that is what the proposed project is. It's not cheap. Unfortunately, nothing in this business is. But when you look at the fact that this city's going to be spending somewhere between $100 and $200 million over probably in the not too distant future on water supply and infrastructure improvements, this becomes pretty cheap to develop a roadmap or a good, strong plan for how we move forward. We've kind of broken this up in a couple of ways. With the basic services would be doing the initial evaluation or the basic evaluation. But we've put some of it under special services, and the reason we did that is, for example, looking at utilizing our effluent either through riverbank filtration or even an ASR project. There's some initial evaluation that can be done that will tell us, okay, there's no reason to explore this any further, or yeah, it looks promising. We now need to take the next step and do some more evaluation. And so that's, we kind of, it gives us a decision point to be able to do that. And if we decide to move forward, then some of the special services will come in play. But it's a total contract not to exceed $574,000. So that is the...
What's the timeline on it, Bill? There you go.
It's realistically, that's a 18-month, 2-year process. I'm hoping that it's more in the 18-month time frame, but it's a big project. There's a lot of evaluation and study to go through this, and so I wanted to point out to you also just that our from our plan to increase our fund balance to a 75-day cash on hands is moving forward. Our projected fund balance at the end of this fiscal year is a little over $3 million, so that is moving us definitely in the right direction. That'll be about 50 days cash on hand, so I think that we're on track with our 5-year plan. We won't see this type of growth every year, obviously, because of weather conditions. Probably, we talked about yesterday at the council budget hearing, is that, our revenue is cyclical, it's weather related, and so we look at it over the 5-year period. And I think our projections for next year are not to, we probably won't make up as much ground as we did this year, but we are on track with that 5-year plan. So.
Will you be sure and take that to council if we make the recommendation on the study? I want them to know that we've gone from whatever it was, 13 days to 50, and we want my recommendation in talking about it and looking at this is that we stay with the plan and we get to our 75-day goal, and then we reevaluate water rates like we told the public we would.
We'll leave this slide in here, but we did talk about that yesterday at the budget hearing.
Good.
So my request and recommendation to you is that you recommend that we move forward with this project.
Question?
I missed the May meeting, unfortunately, so I'm a little behind. I just want to throw a few things out there. I know the Alan Plummer, it's Alan Plummer, right, that's doing the...
Yes, that's who we're proposing.
That they were going to look at the 2016 Region F water plan and the numbers associated with that, correct? Region F 2016 plan, I believe, is what they were going to base their numbers off of for the water supply.
For population projections or needs?
Or just actual for all the various water usage?
Yes.
Based upon municipal irrigation, all
Yes,
that?
yes.
The new, as you know, you and I are both Region F voting members. The new plan, the 2021 plan, has knocked about 53, and I didn't do each 10-year. I did 2020, 2040, 2060, looking at them. The main thing for Tom Green County is it reduced the irrigation from 94,000 acre feet a year to around 42,500. And it cut some of the smaller livestock, some of the mining, manufacturing. But what we're looking at now, as far as Tom Green, and I'm talking about just directly Tom Green County, which is most of us pretty much, We're looking at somewhere around from 120,000 projected for 2020 in the 2016 plan, somewhere around 66,000 acre feet of water now. So, I mean, you're talking about an increase of anywhere from 53 to 52,000 acre feet of water, a decrease, I'm sorry, in those, and I just did 2020, 2040, 2060. That's a significant decrease, and that's mainly in irrigation. And the reason I'm being cautious with this is because the Lipan Aquifer and the people out east, the farmers, I mean, the Freeston Nichols who did the 2016 plan, they looked at the actual irrigation numbers. And when this 2016 plan was being created, it was being created in 2012, 13, 14, when we were all in dire straits and thought we were going to run out of water. So they used the maximum values of no rainfall and maximum irrigation and all that. And now that they've gotten some, Freeston Nichols has gotten some numbers from the Lipan Kickapoo Water District, they see that those numbers for the irrigation aren't near what they thought. That being said, if we do have those additional supplies, I would hope that Alan Plummer would use that in their calculations, as you had talked about, maybe putting water downstream and then taking it out of the groundwater. That could make that a higher priority and a less cost per acre foot, because we are, the water availability is significantly increased on us. We're not using as much. And like I say, it's a lot of it is irrigation, but they've got some years under them now with numbers that show that, hey, this is worst case scenario, this is what we designed for, but in reality, this is what was used. So I hope that they will take that into factor.
Yeah, absolutely, Chuck. That's a really good point. And we've had that conversation with them. For one thing, my projections are lower than what the current Region F is. I think their projections were too high.
Yeah, I think, and that's a good thing, because the municipal demands 2020 through 2070 for you guys, for Tom Green County, for the municipal needs, they stayed the same. They were just based upon a population increase of a certain percentage.
Right.
So they were, they're around from 20,000 in acre feet in 2020 to about 25 and some change in 2060. So
Yeah.
it's based upon the population increase.
Right.
So that all stayed the same. The thing is there was some negligible stuff on the livestock and the mining and the industry, but the big thing was the irrigation. And a lot of that too is irrigation practices have become better. There's a lot of not just flood irrigation, it's drip and subsurface. So there's some, I would hope that would be looked at, because there may be some additional water there in that as groundwater that we could get at a significantly cheaper cost than we originally anticipated.
Absolutely. And I mean, I think that's, to me, that's the purpose of doing this, is to evaluate all those. And there's going to be we built into this a lot of interaction. They're not just going to go off and then come back, because we want to be able to, as we move through this, information that you have and everybody has, that we get to build into this discussion and evaluation.
Yeah, I'm really interested in being able to put some of that DPR in, have it go down to 8 miles, and see if we can do the wells on the bank wells and be able to pull that water out. I think that's a strong source for us, so I like emphasis on that project. That makes sense. And when you go back and look at what other cities have done and acceptance by the public, and we've talked about that, then that seems to be a strong middle ground for everybody. If we can put that in and let it filter down and then take it back out.
I think another thing maybe too, you're talking about some potential Fort Stockton water and some municipalities out west potentially purchasing that. It's going to be pretty costly to build a huge, plant or pipeline that goes from Fort Stockton to San Angelo. But it could be possible if we could negotiate with some of those cities to potentially, if they're going to use that groundwater, maybe we can trade with them, pay them an amount of money, and pay them to get a little bit more of their Ivy and their Spence water. We've already got those, and that may bump those cost per acre foot down to where, we could, but obviously that's going to be long-term. You're going to have to do a lot of negotiating with various people if they do that, but that's another option. That
you save all that infrastructure cost on that pipeline.
An infrastructure cost from out west to here would be expensive, but trading them another 5,000 or 10,000 acre feet for Ivy and Spence probably wouldn't be.
I guess my only question has to do with the timing of this study. I'm very encouraged about how the capital or reserve balance is growing. At what date do we expect to meet that goal of 75 days, the way it's tracking now?
In 2019, I believe, is when we anticipate having the 75 days.
Okay. Since this is a long-term view of this study, is there a sense of urgency now, or would it be more prudent to wait till that fund balance reaches our goal before we fund this?
My answer to that, Judge, is there's a sense of urgency. We need to move forward with this. We can't do anything until we have a plan. And we have 35 months supply right now. We've been holding at that for a while, fortunately, but that's still not a lot. And if it quit raining, we wouldn't have a lot of time to pull something together. So I don't think, we have the funds in our budget for this study, so I don't think there's any value to us to wait. I think the important thing is to move forward.
Stan?
Kind of in a similar vein on the timing is, I know that some of the permitting on that bank drawdown, whatever that project would be called, but some of that is, 2 and 3 years in the making. And if this is taking 18 to 24 months, are some of these other things still tracking and getting done? Are you able to do that, or is it a total standstill on kind of all of these other options until this plan gets adopted?
No, we have to understand what our wastewater treatment plant is going to be before we can begin the process for getting a discharge permit, which we do not have. So that'd be the first thing, is a TBDS permit for the wastewater treatment plant to be able to discharge into the river. The second piece of that is a bed and banks permit, which takes even longer. That's probably a 5-year process. Both of those would be started as soon as possible.
But as soon as possible after this study?
Yeah.
During the study.
Let's
at
do it
whatever
now.
point.
That's what our question is. Can we do it together? Let's
Parallel
start
track.
on the
I understand the point,
embankment deal now.
and that's the answer. You can't start at the beginning. There has to be a certain amount done before we can start those. So that the initial, or whatever piece of that has to be done, what the timing of that is in there, I can't
Well, and if
tell
your
you right
study that deems that that's not a viable deal, then you've already too far down the track, you've wasted that money. I mean, that's the predicament you get in, right?
Yeah.
I don't know. That's.
Roland?
I've got a comment. Bill, so I commend you because I think this is a project that we've been looking forward to. So I commend you on the foresight. I do believe we need a roadmap that tells us when we need to pull the trigger on these particular projects and know how to finance and expect the timing on the projects. I think the only question I have is this a recommendation coming from an RFP, or is this a recommendation as an addendum to an existing contract?
No,
It was
this
an
con-
RFP that was sent out, and 3 submitters were submitted to the
March of
RFP.
17, right? 317 contract? I mean, it was an RFP, was,
Yes.
Yes.
Is that your question? Yeah. After August, when y'all made the recommendation to move forward, we completed developing the scope, put it out on the street, got responses, and going through the process. Now we're asking to award that contract.
Other questions?
So some of the things that I heard, we talk about, I've heard about the Fort Stockton or whatever, and the West Texas Water Partnership, that of course we know nothing about, and the current status of the Hickory, which we know nothing about. Is there anything else that we don't know about that maybe should be factored into all these decisions?
Don't know. I'm not sure I understand the question, but.
Well, the question is that we seem to be always left in the dark, and except coming to ask us for a recommendation to spend more money. And so that gets a little frustrating at times. So I believe that this needs to be done, okay? I believe that it's the right thing to do. It's just, what I always hate is not seeing the full picture and not knowing everything that's out there. And I'm looking at you and pointing at you, but it's not you, and I know that. It's probably more like the guy that's sitting behind you. So You know, that's the frustrating part for me, okay? As the member up here, that I feel like a lot of what we do, we're done kind of in the dark, okay? This needs to be done. I'm not in disagreement with that, but we don't know where we are on the Hickory, which we talked about, what, a year and a half ago? We don't know, you know, the water partnership, you know, I think we've asked about kind of where some of that stuff is, and it's because that plays into the factor of all this stuff, and I don't quite know if we can't hear about it, if we can't know about it, then how can Alan Plummer know about it?
Well, I think you're confusing some issues there. I don't think Alan Plummer's going to know about those things. Let's talk about the Hickory for a minute. The Hickory is at currently 9,000 acre feet that it can produce. The max is 12. If we had it completely built out today, would it change the need to do this? To me, not at all.
I'm not in disagreement with that. That's not what I'm saying. You know, but when are we going to get when is that the well field going to be expanded?
I don't have that exact date for you. We're going to move forward with that project just as soon as we can. The council has indicated they want to do that, so we will do that just as quick as we possibly can.
And then the next question would be, you say you've got the money, how are you going to pay for it? Where's it coming from?
We have the money in our budget to pay for this study.
In your general fund budget?
It's in a capital fund budget.
Bill, I just want to echo a little bit of what Kendall said, and I think you've got a great board up here. You've got a lot of people that have been here their whole lives that are very passionate about what happens in the community, and it would be really helpful to us if you would keep us in the loop and keep us informed, because we want to help you guys too. We know how difficult your job is. It's not easy to find water for 120,000 people when you're on a limited water budget. So we totally understand that, and we want to help you, but we'd like to be kept in the loop as well and help with that.
Absolutely hear you. Appreciate it. I don't feel like you haven't been in the loop. And we don't need to get into that anymore as far as this project. From my perspective, y'all made a recommendation. I went off to do it. Now, granted, I'll be the first to admit we should have kept you more informed of where we were in that process. But we went through the process. It wasn't something you weren't involved in. It wasn't something, it was just a time period there. Okay. Other than that, you're in the loop. Can I talk to you specifically about all of the issues with Hickory? No, I can't. Can I talk to you about all the issues with the West Texas Water Partnership? No, I can't. But they don't come into play on this issue. The West Texas Water Partnership is long-term. So we've got to get to that point. The Hickory is going to be expanded, but it doesn't, even if it was there today, it doesn't change the need to do this. So I appreciate what you're saying, but to me, it doesn't change the importance of making this decision. I hear you loud and clear, Chuck.
We're happy to help you too. I know how tough it is.
Yeah, we're
And
not.
we will do that.
And this is for whoever's in the audience or tell the council, you know, we're the front for water from a public's perspective in my mind. And we get asked questions, and you and I have discussed this, and we can't answer them because there's certain things going on that since we're an appointed board, we're not an elected board, that we don't have the privilege of knowing. And it just puts us in a very difficult position when we get asked specific questions and we say, I don't know. And so my message to council is whatever can be communicated to us, it needs to be communicated so we can answer those questions the best we can. If it's a litigation matter, then that's a fine answer for me. I can say it's in litigation and I'm not able to comment on that, but I need to have the information to say that. Does that make sense? So I'm not directing that at you. I'm making that comment to take forward to council to let us know as much as they can about any situation, so can we at least respond to it. Does that make sense?
They were far more eloquent in what I was trying to say. So I wasn't beating on you, Bill. You know that.
Well, I
wasn't.
practiced that a little bit. So.
It's right that we want to be here. We're all in this thing together, and we're here to help the city. That is why all of us volunteer for this. That's why we're sitting up here. because we want what's best for the city. I want to look long-term for the water for my kids, for my grandkids. I mean, that's the thing that we've got to look for, because it's not just, the water is so vital to this community. It's economic development beyond anything that we can even imagine. Roland can't bring in enough jobs if we don't have water. So it is that vital that we get this thing done. Just,
Got it.
we feel like we're kind of left out in the dark on many, many topics. We do. And it frustrates us. Okay?
So with that being said, I'm going to call for a vote on recommending to the city council that we approve or disapprove this plan.
Motion in a second
Yes, sir.
first, or are we just going to vote?
Need a motion?
I'll move to approve. I have one question too. Are they going to also look at the water treatment plant and potential, I mean, I know that's some stuff too that needs to be, and how much money for different things. Is that going to be a part of this?
It is.
To look at the water treatment plant?
Facilities and then,
Both the water and wastewater.
And I'll second that.
I got a motion by Chuck and a second by Kendall. Further discussion? All in favor, say aye.
Aye.
Any opposed? Motion carries, Bill.
I'm going to move forward.
Okay. Any other items? I think we've addressed everything that I had. Cash on hand, days cash on hand, overlay of infrastructure, Hickory, and this project. Anything else to come before us today?
And like Bill said at the beginning, I wanted to go ahead and
Set a date.
let's set dates. I would like to meet, or if y'all desire to meet, like the beginning of October and a meeting in December. And we'll try to schedule it the 1st of December, or whatever works best for y'all. I know that holidays get messy, but if there's a particular time, the 1st of October, that works for y'all.
10th or 11th? What's it, well, 10th, is that council?
No, council should be the 3rd, so that would be in the off week of council. You said the 10th or the 11th. The 10th appears open.
Looking.
If that
We'll
works
set
for
it
you.
here in a minute before we leave.
And the timing, I'm going to get, whether it's a morning or afternoon meeting, I'll get with the city schedule to make sure there's not a current board
Conflict.
meeting. So as long as y'all give me a day range, we'll go from there.
October 10th or 11th?
I'm out, but
Mentally or physically?
you be the judge.
I'm good on both days.
And also, as it
Not
gets
a
closer, you know, if things come up, we can obviously reschedule. But I think it's best if we have a date in mind and we move forward with it. And then we'll schedule the December one following the October meeting.
Can we look at that? Are you okay with that?
I'm fine.
10th or 11th?
Okay.
Let us know. Any other business to come before us today? If not, we're adjourned. Thank you.